for today was number 12. So we're going to solve it using series. We assume that y is an infinite series of Cn x to the n, so we compute our y prime using the power rule. Jumps us up to n equal 1, Cn times n x to n minus 1. Then we need y double prime again, following the same pattern, n equal 2, Cn n minus 1, x to n minus 2. And we're just going to plug those series into our ODE. So I do 3 times the y double prime formula. And then minus x times the y prime formula. And then plus 5 times the y formula. And then we want to start simplifying things. First we need to move everything that's power x inside the sums before we can start balancing our sums. So in that middle term, I'm going to take the x from out front and try to move it inside my series. Doesn't affect my coefficients, but I do take that to x to n. That's because I have n minus 1 plus 1, just becomes n. And then my last series is unchanged. And then from here, I want to get everything to the same power x so that I can start combining my series. So I want that x to n minus 2 to become n. So I just have to add 2 everywhere that I see an n. My n minus 1 becomes n plus 1. My n becomes n plus 2. And then I have to change that lower bound of my sum. I can just check. Originally, I wanted to start with c2 times 2 times 1 x to 0. So if I plug in n equals 0 to my new term, I'm going to get x to 0 times c2 times 2 times 1, so it works out. And then my other 2 series were already at x to the n, so they don't change at all. Now I want to make sure all my sums have the same lower indices. Since I've got 2 n equals 0, I'm going to try to take that middle term to n equals 0 as well. I'm moving my 3 inside just because I like the way that looks. And then I put a square bracket around so that I remember to distribute my minus on that sum. Be careful here in general. And since I moved it down to n equals 0, I just want to take away that extra index or that extra term when I plug in the index n equals 0. So I subtracted that c0, 0, x to the 0, last sum unchanged. And subtracting that term actually didn't do anything, so I can go ahead and just combine my 3 series as they are. If that last term did stick around, I would just use that for that second relationship that we used to solve for all our coefficients. So then the thing that multiplies x to the power n has to be 0 in order for this to equal 0 for all powers x, all values x. So what I've got is that whole thing inside the square bracket is equal to 0. I'm going to try to copy paste it to the next slide. Went okay. At some point in this video I copy paste something poorly. So I want that to be equal to 0, so I'm just going to solve for Cn plus 2 in terms of Cn. It's just an algebra problem. But I had dropped that minus sign, so I just had to fill it back in. And now everything looks okay. I can go ahead and solve for Cn plus 2. I get n minus 5 on top, and then 3 times n plus 2 times n plus 1 on bottom, all times Cn. The problem with this is that your web work does want it in the form where you've got like Cn equals something in terms of Cn minus 2. So we're just going to take that approach of subtracting 2 everywhere we see n to get that in the form we want. So I've got n minus 2 minus 5 on top, then 3 times n minus 2 plus 2 times n minus 2 plus 1. And then that turns our last into Cn minus 2. So I'm just going to simplify all that. Since I will be plugging in, it's going to be easier to look at it in a simpler form. And then this is going to be something that you put into your web work right here, that relationship. there's going to be like a weird aside about writing y in terms of c0 and c1. It's going to be c0 y1 plus c1 y2, where they tell us that y1 has to be our even functions and y2 has to be our odd functions. Remember, that means y1 is going to be even powers x, so y1 would be something like x to the power 0 plus x to the power 2. I wrote that wrong. But the point is that when we plug in 0, we're just going to get that x to the power 0 or 1 out of it. And then our y2 is our odd powers, x to the power 1, x to the power 3, so on and so forth. Importantly, when we take the derivative, that becomes 1 plus some x to the power 2, and when we plug in x equals 0, that just leaves behind 1. So what that tells us is that y1 is going to matter for our y of 0 condition. For me, I had y of 0 equals 3. I'm going to consider y1 to actually affect reaching that value. That means my c0 has to be 3. And then my y prime of 0 was also 3, so y2 is going to affect that, and so my c1 has to be 3. I had kind of an easier time of it since my y of 0 and y prime of 0 were the same. I could have just plugged in 3 in both boxes, but I wanted to talk through that just in case you all had a more complicated problem. So that's the middle part of your web work. And then from here, we're going to continue with trying to evaluate all of our coefficients. So I'm going to try to snag that definition of the coefficients to use on the next page. But I really struggled with the copy-paste tool. All right, there we are. That's the formula I want to use, and I need to get, first I work with my even powers, and then for the odd powers, we just write the function. So I just proceed with calculating C2 from the formula, plug in n equals 2. And it's going to depend on C0. I'm going to leave it in that generic form to start, where I don't actually plug in C0 and I don't simplify anything. And then I think about how I'll sort of rearrange it as a function later, or as a special pattern later. I think I need up through C6, so next I'm going to do C4, where I plug in n equals 4. I don't know if y'all heard, but a little kid was late for her flight just now. And so that simplifies to minus 3 over 3 times 4 times 3 times C2. And when I plug in my C2 results, again, I'm not going to multiply things out because it helps me to see the pattern if I leave everything sort of in this form. And then I continue on to C6. Eventually. There we go. So I'm going to plug in n equals 6. This is usually not the part that's going wrong for you all. It's in the web work marking it correct. But to get to that point, I do have to work through it all. And then again, I'm bringing together all my terms, but I'm not simplifying them. I am going to rearrange them here, though, so I can kind of like show you all the pattern I'm seeing. I've got 6 times 5 from this one times 4 times 3 times 2 from the prior one. And I think I'm going to show you all where that came from. Yeah, right there. And then I'm left with these 3 3s. So I've got 3 to the power 3 times all that. And if you look at the prior one, I'm going to have like that 4 times 3 times 2 times 3 to the power 2. And then if we go back to the very start, I've got 2 times 3 to the power 1. And so kind of the pattern we're getting out of this is that there's a factorial and a 3 to the power, like n over 2. And then up top are like odd factorials where we only grab some terms. So you don't need to find a pattern for this one, you just have to plug in the values, but just to get you thinking, because finding the patterns is part of some problems. And so as far as like what you need to plug into WebWork, unfortunately it's going to be the thing that's multiplied by C0. So like for that first C2, it's going to be that minus 5 over 2 times 3. For C4, it's going to be this 5 times 3, because the two negatives canceled out, over 4 factorial times 3 squared. And then for this C6, it's going to be the minus 5 times 3 times 1 over 6 factorial 3 cubed. And I'm about to circle that just so that you can see exactly what I mean. It's just the part of your coefficients that's not coming from the C0. And this is frustrating because it's not consistent with how it was asked for in your homework last week. I'm sorry about that. I don't like it either. For the very last part of your web work, you gotta find that function y2. And remember that this is gonna come from our odd terms. So we're gonna start from C1 equals 3, and then we have to calculate like C3, C5, C7, etc. So for C3, I'm just going to follow the formula, plugging in n equals 3. Struggling with what 3 minus 1 is right now. And then we just go ahead and I'm simplifying a little bit, but not a lot. And then C5, we plug in n equals 5, and C7, we're going to plug in 7. Caught that I wrote that minus 1 wrong to start. Just going to keep combining terms. Again, probably this plugging in isn't the issue that you all are having, but I gotta do it to get to the point where I can show you the answer. And then you notice when I plug in n equals 7, I get 0. And since C9 is going to depend on C7, it's also going to be 0. And so our Y2 is only going to have terms from C1, C3, and C5. And we're actually asked to plug in what Y2 is, so I wanted to start simplifying what these coefficients are going to be. So my minus 4 and 2 on bottom can cancel out. I've just got minus 2 over 9 times C1 is 3. And then C5, my 2 and 4 on top can cancel with a 2 and 4 on bottom. So I'm just left with 1 over 5 times 3 times 3 squared, so 5 times 3 cubed, times my C1 is 3. And then C7 was 0. And then after you've done this, you got to go ahead and plug it all into the Y2 that actually has your powers x in it to get your final answer. So Y2 is going to be C1 times x to the power 1. There we go. C1 x to the power 1 plus C3 x to the power 3 plus C5 x to the power 5. Nothing else after that because our coefficients go to 0. And WebWork wants your answer with C1 factored out. So my C1x is just 1 times x. My C3x cubed, I just pull that 3 for C1 out front, so I only do that minus 2 over 9 x cubed. And then for my C5, again, I'm just gonna remember that a C1 3 has been pulled out front, and I only do that 1 over 5 times 3 cubed on the bottom, x to 5. And the thing that I've underlined, or the thing inside square brackets, is what you'll put into that final box on your web work.